solving square root and other radical equations. When we are doing this, we've actually been doing this in algebra for a while now, but a radical equation is going to be an equation very similar to what you see right here, but it's going to have a radical somewhere in the equation. And of course, if it's a square root equation, that just means that your index, let's see here, just in case you've forgotten, right here is going to be your index. That when your index is 2, then that indicates a square root equation versus some other root equation. And of course, our extraneous solutions, that is a solution that when we go back and check it, it doesn't work. So you would have to discard that because it's not a true solution. And what we can do now is when we are working with radicals, the first thing we want to do is we want to isolate the radical. It's got our variable in it. We want to isolate that and get everything else to the other side of the equation. So we'll do that using inverse operations, moving the 5 over to the other side. And as I do my inverse operations, of course, we're going to go ahead and move that 5 to the other side by adding 5 to both sides. So it's going to be the square root of 4x plus 1 equals 5. Now still, in order to isolate our variable, we are trying to get our variable by itself, and we are not trying to get the square root of that variable. We want the variable itself. So we know that in order to get rid of our square root, we can square our radical, and then by squaring our radical, we have to square both sides. So then we know that we get this becomes 4x plus 1 equals 25. Continue with your inverse operations to isolate your variable here, and we get 4x is going to be equal to 24, and finally x is going to be equal to 6. And when they talk about extraneous solutions, we always like to forget, let's go back and we forget to check it. So if I do check it, 4 times 6 plus 1 minus 5 is 0. Well, this is going to be the square root of 25 minus 5 is 0, or 5 minus 5 is 0. So that is a true solution. There you go. X equals 6. Okay. There's a typo here in this next problem. So it says, what are the solutions for 2 times x plus 3 raised to the 3/4 power equals 8? And what I need you to do is I need you to go ahead and correct that. That should actually be to the 2/3 power. Sorry about that, but sometimes we have typos. And as before, what we're going to do here, we are going to try to isolate our variable first. So we're going to isolate that grouping symbol that the variable is in, the parentheses. And in order to get those by itself, what we can do is we can divide everything by 2. And that is going to help to isolate that variable. When we do that, of course, our 2's are going to then cancel out. It's going to become 4. So we can now rewrite our problem as x plus 3 to the 2/3 equals 4. And we're not working, we have an exponential fractional exponent, and it would look like a radical, but without putting it in radical form, what we can do is we can multiply it by its reciprocal in order to get it to the value of 1. And in doing so, if the exponent is 2/3, then we would multiply it by 3/2, and that raise it to 3/2. And if we do it to one side, we must do it to the other. And what happens here is our exponents, then we multiply our exponents because of our exponent properties, and then that gives us x to the 3rd to the 6 over 6 equals 4 to the 3 halves. And, of course, 6 over 6 becomes 1 over 1, or just 1. So I have x plus 3 is equal to 4 to the 3 halves. Now, if you don't remember, I mean, you could put this in the calculator just like it is, and it's going to give you the answer. But also, if you think about it, if we use the radical, we have the square root of 4 to the third, which is the square root of 64, which is plus or minus 8. So we can come over here and continue solving our equation, and we know that x plus 3 is equal to 8, or x plus 3 is equal to negative 8. Do your inverse operations, isolate your variable, and in doing so, I find out that x is equal to 5, or x is going to be equal to negative 11. And there you have it. We end up with two solutions. If you go back in and you check these solutions, you'll find out they're both valid. So they both check, and there you go. X equals 5, x equals negative 11. As we develop in our skills and we get a little bit more difficult problems, you notice we have two radicals here. And what we're going to do is we're going to isolate one and then turn around and work to isolate the other one to get rid of our radicals. So we can start with, what I'd like to start with is by getting this one by itself. So we can go ahead and add the square root of x to both sides. And that is going to now be rewritten as 5x plus 4 is going to be equal to the square root of x plus 4. And to get rid of this first radical again, we're going to square it. And if we square it, we have to square both sides. And we know that, again, that these things are going to cancel out. So I'm going to have 5x plus 4 is equal to, when I multiply this out, just so you know, this is what it looks like in case you've forgotten. And don't forget to do whatever FOIL method, box method, distribution method you want to multiply these two binomials together. But you're going to get something along the lines of that. And simplifying that, you have x plus 8 square root of x plus 16, and still have 5x plus 4 on our other side. So now that we have just one radical left, what I want to do is I want to work to isolate that radical. And in doing so, I'm going to subtract x from both sides, and I'm also going to subtract 16 from both sides. And that is going to allow me to isolate my radical. And I'm going to end up with 4x minus 12 is equal to 8 square root of x. In order to, again, to get rid of this radical, I need to square. And if I square it, I need to square both sides. And this will work out to be 4x minus 12 times 4x minus 12. And this is 64x. Now I'm going to go ahead and combine like terms, but in order to do that, I should probably multiply this out so we can see it a little bit better. Okay, so I've gone and multiplied that out, and we have 16x squared minus 48x minus 48x plus 144 equals 64x. And go ahead and do my inverse operations to combine like terms. And I believe I end up with that. 16x squared minus 160x plus 144. And I am going to simplify this a little bit. I'm going to divide everything by 16 because it's going to give my numbers, make my numbers a lot smaller. And I am going to get x squared minus 10x plus 9 is equal to 0. You're going to use your zero product property. To factor that, you're going to have solving for x equals 9 and solving for x equals 1. And if you go back and check these answers, let's see here, we're going to have let's check our 9, right? We have the square root of 49 minus the square root of 9 equals 4, which is going to be 7 minus 3 equals 4. 4 equals 4, so yes, that's good. X equals 9 is a good answer. And if we turn around and we check our other one, this is where our extraneous solutions come into play. They want us to check this to see if it is going to be a true statement or not. And when we do, we find out that this becomes the square root of 9 minus the square root of 1 equals 4, or 3 minus 1 equals 4. 2 does not equal 4, so therefore that is not a good answer, and we only have one solution, which is x minus 9, or I'm sorry, x equals 9. Now, I hope that was clear. This is the third time I've had to do this. We have a tornado warning right now, and it's a bit noisy and thundery outside, losing power, but again, we're going to isolate our first variable. Then, as we see, we were able to FOIL, isolate our second variable, and then eventually find some simple solutions, plug them back in, and check them.